No. So this week we're looking at requirements engineering. And when we talk about requirements, we are focusing now on the software. In the previous weeks, we have been talking about the whole organization, how it is that a software company works, software engineering company works. We've talked about the process models, the different ways of going through the development of the software itself. We've spoken about the project management side of it. So all we've been doing is really skirting around the whole issue. So now we really need to get into software engineering itself, and a big part of it is requirements engineering. And requirements engineering is getting from the user what it is that they need and taking that information, modeling it in such a way that you can come up with your software product. Everything else that we did before was to help you do just what you are going to do now. All right. So, topics covered: functional and non-functional requirements, the software requirements document, specification, the requirements engineering processes, elicitation, validation, and management. All right. And I may jump backwards and forwards from both slides, sets of slides, but this one covers everything, most of it anyway. All right. What you'll find in the other set of slides that I sent you on Tuesday, it has a little bit more on the agile process and XP. But I'm focusing here. This is really on plan-driven development or the waterfall process, okay? But it does apply to all of the processes. So what is requirements engineering? The process of establishing the services required from a system and the constraints under which it operates and is developed. What do we mean by that? Anybody can comment on that? What do we mean by this slide? Think about it. Requirements engineering is the process of establishing the establishing the services required from a system and the constraints under which it operates and is developed. What does that mean?
Does it have to do with the features? If you are developing an app?
It has to do with the features, yes.
That's what I think.
That's one part of it. Anything else? There's a term there that you haven't addressed. The constraints. The constraints. Yes. What do we mean by the constraints?
Still thinking about it. I don't know constraints in what context.
All right.
It should probably mean like certain conditions that it needs to meet in terms of maybe like how fast it must do something. Like that you mean as a constraint?
That can be a constraint. All right, now thinking back on your assignment, what is it that you're supposed to do in that assignment? You're supposed to develop a what? What sort of app?
Diet suggestion app or something like that.
It's a food management app, isn't it? Yeah? And where are you going to be using that app?
On an Android system.
There you go. You have your first constraint. It didn't say that you should develop this app to use on a PC. It didn't say you should develop this app to use on an iPhone. It didn't say you should develop this app to use where else? Where else could you use it? I'm not quite sure, but it did say Android app. It was very specific. So that means it's going to operate on phones and tablets, any device that uses the Android operating system. So that's a constraint. And constraints are good because it limits the work that you have to do. It specifies what your scope is. Because if you were just left to develop a piece of software, there are so many operating systems that you would have to think about. But you're narrowing it down to where. All right, and that's just one constraint. Somebody mentioned speed before. All right, Miss Lynn, is it Miss Lynn or Antonia who mentioned speed before? So their constraints are restrictions. So requirements engineering is identifying the what it is that the software is supposed to do, and the restrictions that affect the operation of the software. Okay. So the requirements themselves are, is everybody still with me? I'm not hearing any comments.
Yes,
okay. All right. The requirements themselves are descriptions of the system services and constraints that are generated during the requirements engineering process. And a lot of times when you talk to the clients, as I said to you before, they don't know what they want and they don't know how to say what they want. And they also don't know how to tell you what they actually do have. So when through the requirements process, all of this comes out. So what is a requirement? It may range from a high-level abstract statement of a service, and that this is an example of one. The system must output the roots of a quadratic equation. That's a requirement. And you come upon this so often in math, don't you? That is saying, if I ask you to write a program to output the roots of a quadratic equation, that in itself is a requirement of a software system. Okay? A very abstract statement. If you notice, it is not telling you how it must be done. It is telling you what must be done. So requirements do not tell you the how. It just tells you the what. And it tells you your restrictions. Okay. Now, a system constraint in that same quadratic equation, and I think you've all done programming with it for engineering with me, and this is one of the decisions that we look at when we're doing just this example, and that is that A must not be 0. That's a constraint. Because if A is 0, what happens in a quadratic equation?
It's not a quadratic, it is 0.
It's not a quadratic equation, what is it?
Well, it can either be a linear or a constant.
It would be a linear equation. It didn't say anything about B. It just said if A is 0. All right. So that is telling you, I want this to be done. However, this particular condition must exist or must not exist. So you see what the constraint straight away is. All right. A requirement can also be a detailed mathematical functional specification. So all of what you wrote here can be written mathematically. And in writing it mathematically, you would say ax plus bx plus c. Sorry, that should be ax squared plus bx plus c equals 0. So all of these are requirements. Some are functional, some are and they're also non-functional, but they are requirements. When I send this to you, I'll fix this because this is not a quadratic equation.
Oh, this is a different slide from what you sent us.
Yes,
this is different from.
This is different from what I sent you. I will send this to you.
Okay.
All right. Okay. Now, requirements may serve a dual function. They may be the basis of for a bid for a contract. And if they are, it must be open to interpretation. And I'm going to come back to that. It may be the basis for the contract itself, therefore it must be defined in detail, and it may be both statements. Now, in the assignment that I gave you, what I gave you was a set of requirements, isn't it? Think about what I gave you. Isn't that a set of requirements? So if it were that I had published this for requests or proposals and you had to bid on it, then I would have to write it in such a way that it is open to the bidders to interpret what I said. And it actually is, because I have a number of groups, it should be about 5 groups who will be developing a project that I am going to decide which is the best, or for whatever reason. In all actuality, I won't be deciding which is the best. I'm just grading all of you equally. But if this was competitive, I would be looking at what you have come up with, because you would be interpreting what I said and developing your bid for that contract based on that interpretation. So you would develop your own in-house list of requirements, and you would decide how much are these requirements going to cost you to develop. All right? Or it may be that instead of throw it out there for proposals, it may be that I say, look, I want to work with this company. This is your company, and this is what I want you to develop for me. All right, so that's where it now becomes the basis of the contract itself. Okay, and it can be both. It can be both. Any questions? Any questions? All right, let's move on. Now here is a statement that shows, that gives an example of requirements abstraction. As I said, the one that I sent to you for your assignment is one such, but let's go through this. If a company wishes to let a contract for a large software development project, it must define its needs in a sufficiently abstract way that a solution is not predefined. The requirements must be written so that several contractors can bid for the contract, offering perhaps different ways of meeting the client organization's needs. Once a contract has been awarded, the contractor must write a system definition for the client in more detail so that the client understands and can validate what the software will do. Both of these documents may be called contract documents for the system. So this is saying that this is just going over again what was said before. I think the next one will give, no. Oh, I took it out. So in looking back at the assignment that I gave you, do you think it was abstract enough, or do you think I put in details in it?
It was more specific.
Pardon?
I think it had more specific details.
Mm-hmm. And why do you think I would have done that?
It gave us the opportunity to know exactly what you're expecting in terms of the software that will be delivered.
And well, basically all I've done there is save some time.
That's true, yes.
Because in the real world, I would have been a lot more abstract than that and given the prospective developers an opportunity to come to me with what they think I mean, and then I could choose which one. But because we have a time constraint here, we're working with constraints, I need to be fairly specific, and I've left a little bit of I've left a little room for interpretation, but I have just stated that there are some things that I must have. All right, but how those must-haves will be obtained, that is up to you, and there is some amount of flexibility there. Because part of what you will be required to do is get information from me. Now, I could have left it abstract and then have each group call me and interview me for a period of time, for, do a 1-hour interview. But the fact is that this is going to eat into my time and into your time. So I put the information there. But generally speaking, the requirements can be a whole lot more vague than what I gave you. All right, so we have the different types of requirements. We have user requirements. And user requirements are what, as they say, user. The user is the person who will be utilizing the software. All right, so you are going to be identifying that these are particular requirements of the software that the person who is going to be using it will make. Now, don't get it confused. The person who is paying for the development of the software may not be the person who is using the software. And these two people will have different requirements. So, user requirements are statements written in natural language, diagrams of the services the system provides, and operational constraints, and they are written for the customers. So they're not written for a software engineer. They're written in their natural language, whichever language it is that you use, or your natural presentation language. Now, I want you to keep in mind this term here, that user, because the user is an extremely important person. Okay? Now, system requirements are different. Now, that's a structured document setting out detailed descriptions of the system's functions, services, and operational constraints. Defines what should be implemented. So it may be a part of a contract between client and contractor. So the system requirements could include the type of operating system. It can include the type of hardware. It can include certain operational issues. It could be related to the business itself, how the business operates. So those would be a part of your system requirements. I don't know how well you can see this. So this is one time where I am going to switch to the other set of slides where it is a whole lot clearer there. You would hope that it would be a whole lot clearer, wouldn't you? Is that any clearer? Can you see this any better than the previous slide? Hello, am I talking to myself?
No, miss.
It's a bit blurry, but we can make it out. It's a bit blurry, but
It's a bit blurry, but you can make it out?
Yes, please.
All right, so
Yeah, make it out.
all right, so this gives an example of user and system requirements. So the user requirement for this, this is in the software engineering book that I am using here in the slides, they have a few case studies. And one case study is a mental health center, and it has a patient management system. That is a MHC PMS. All right, patient management system. And it says the MHC patient management system shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month. That's what the user of the system wants. Every month, a management report, and that report must show the cost of drugs that each clinic that is using the system generates or prescribes for that month. I'm quite sure you understand all of that. Yes?
Yes, somewhat. There was a question what did you ask?
Yeah.
I want to ask you. They said that it must have a downtime more than 5 seconds. It's like, whoa.
That's on this?
Well, no, not here, but the slide they gave us to read through.
Okay. Well, this is in the slides that I gave you to read through, but I'll get to that. No, the system requirements specification.
Miss, I have a question.
Mm-hmm. Go ahead.
I was just asking, with the user requirements, could you think of it as black box testing and system requirements as white box testing?
No, you're gone into testing. I am not into testing yet. You're thinking of what type of testing you would use on to validate the software. We're not there yet.
Oh no. As in on the basis of the fact that with the user requirements, it's you just want to know the input, basically like what you put in and what to get out. While the system requirements is what exactly it's doing in order to get that input output. That's what I was referring to.
Yes. Yes, that is quite true. Because as you can see, that the user requirements just gives a general statement. But the system requirements now gets very specific in that it says, on the last working day of each month, a summary of the drugs prescribed, their costs, and the prescribing clinics must be generated. That was included in the user requirements definition. But also in the system requirements, it says the system shall with the system requirements specification, it tells you exactly when the summary must be generated, the last working day of each month. It doesn't matter if the month ends on a Saturday or a Tuesday, it is the last working day of each month that report must be generated. 1.2 says the system shall automatically generate the report for printing after 17:30 on the last working day of each month. So you're getting even more specific. Not only in 1.1 tell you that it's the last working day, what must be generated, but it's telling you also the time and that it must be generated for printing. Okay. 1.3 goes on to say a report shall be created for each clinic and shall list the individual drug names, total number of prescriptions, the number of doses prescribed, and the total cost of the prescribed drugs. So you're getting very specific here. And this is saying exactly what the software must do in order to achieve one. So you have the user requirement, that definition 1. User requirement, definition 1. But the system requirement now speaks to what the software should do. The user requirement says, the user is saying that this is what I want. And so the system requirement now has to go into detail to say exactly what it must do. 1.4 says, if drugs are available in a different dose, separate reports shall be created for each dose unit. So you know some drugs are have different milligrams. So for each of those units, separate reports must be generated. How many people were prescribed this drug at this dosage, the cost of this dosage, so that is done. And in 1.5, it says access to all cost reports shall be restricted to authorized users listed on a management access control list. So it is saying exactly who should get those reports, who should be able to see those reports. All right, and all of those relate to the one user requirement definition.
Is this a requirement from the client, or this is what the contractor will be telling the client that he or she will be embarking on?
All right. So remember we said that we have the a person on the team called the analyst, the systems analyst. So the systems analyst will get from the user, well, I need the system, whatever you develop, to generate monthly management reports, and it must show me the cost of drugs and which clinic prescribed the drug for that month. Now the analyst will take that and they will break it down to the different system requirements, and that will be presented back to the user and say, is this what you want? Because the user is not saying exactly in detail what must be done in the software or what should be created. They just say that this is what I want, an output that will give me this information. But the analyst will take it and break it down. And to break it down, they have to understand how the user does their work. So it's not just about looking at that one statement and saying, okay, well, from that one statement, I can get all of these. They can, if they have experience in developing this sort of software or experience within the pharmaceutical and patient management type of environment. But if they don't, what they're going to have to do is go into the facility and see how the facility works. And they can communicate with the persons who are working in that facility to understand what it is that they need. But all of that comes into elicitation, which we will do later on. Okay, does that answer your question, Mr. Frater?
Yes, thanks much.
Okay. Anybody else with any more questions on this? Okay, let's proceed. All right. Readers of different types of requirement specifications. So you have your user requirements and your system requirements. Who reads what? So the user requirements are read by the client managers, end users, client engineers, contractor managers, and systems architects. Okay, so that's basically everybody. Anybody can read it. The client managers are the persons who would be the ones who would be managing the operations within which the system is supposed to be used. The end users will be able to say, okay, let me see what requirements you have. Yes, this can work for me. This is what I want it to do. I want this software. Yes, this sounds good. The client engineers, these are the persons within the customers or the client's team who will be the ones who will be doing general maintenance or operations, or responsible for the installation and general day-to-day maintenance of the software. Because in any company you go, you have an office there where these persons are your IT persons. So those are your client engineers, okay? Or they'll have their own team of IT personnel. So that's who the client engineers are. Your contractor managers, so the persons who will be the ones who are, you're going to be contracting out parts of the job to. Or on the user side, the persons who are contracted to work with this company, again, they need to know what it is that this grant system is going to do. And the systems architect, who is the analyst. So those are the persons who would read the user requirements. Now, in terms of the system requirements, those are a little bit more specific. Coming back again to this term, users, your end users, a very important set of people. You see this set of system requirement specifications that we have listed here? All of these will have to be checked by the actual person using, who will be using the system. They will have to say, yes, I want all of these, or no, some of these I don't need. All right? So therefore, the system end users must be able to view the system requirements. They will view the user requirements, but they must be able to view the system requirements. Who is it that you don't see in here? Who don't really need to see the system requirements?
The client manager.
The managers, the ones paying for it. They don't need to see it because they're not using it. They will be told exactly what the system will do, but the person who is going to review those system requirements are the end users. The client engineers, the ones who will have to install it, the ones who will have to take the day-to-day complaints from the end users. They need to know it. They need to know what the system can do. The system architects are the ones who are developing the system, and the software developers, which the development team, who will be the ones that the system architects send off the requirements to do the modeling itself. So those are the persons, the engineers and the end users. Those are from the client side. And the software development side are the architects and the developers. I have been using the word analysts and developers. Okay? So those are the persons who see what the requirements are. The system requirements are, I should say. All right. I am jumping between slides. Let me go back. I don't know which is which now. No. One, yes. All right, now one of the reasons why I wanted to switch from the other set of slides is because I wanted to focus on this, the IEEE Software Requirements Standard. Now, everything we do as engineers, we have to do them based on a certain set of standards. We can't just make it up as we go along. And even if we do, we only do that because we are the initiators of a certain set of tasks or a certain set of ways of doing things. But after a while, you must develop standards so that anybody doing the same task can follow certain rules. So that when they do follow these rules, you know that the quality of the product is going to be good. Now, in software development, there are two standards that are mainly used. You see the other one mentioned in the other set of slides, but I want to focus in on the IEEE software requirement standards because IEEE, as electrical engineers, governs all of what we do. Okay. No matter what country you're in, even if your country has other standards, there's still a subset of the IEEE standards. Now let's take a look at each of them. The basic issues that the software requirement writers shall address are the following. Functionality. So that's one of the standards. What is the software supposed to do? External interfaces. How do the software interact with people, the system's hardware, other hardware, and other software? So it must be functional, must be able to do certain things. It must be able to do what it says it is supposed to do. It should be able to interact with people, with the hardware on which it is supposed to operate, with other hardware, meaning that it should be able to print or display, that sort of thing, and with other software. It may be able to obtain input from other software or send information as an output, which would be an input to other software. So it has to be able to interface. Now the performance speaks to and I think this is what you were talking about earlier on, Mr. Lin. What is the speed, availability, response time, recovery time of various software functions? So within the requirements themselves, the performance of the software, the expected performance of the software needs to be stated. How fast does it respond? All right. How fast does it take to carry out a particular process? Availability. How is it always available to be used, or is it going to be working in the background, or is this going to wait until other software do what they're doing, and then it does what it has to do? Response time. When you press enter, how soon do you get the response that you're looking for? Now, another one that is very important, recovery time. If anything goes wrong and the software has to shut down, or the software has to reboot or get back to the point at which it failed, that is your recovery time. And you don't want that to drag on. I don't know if you notice, sometimes you're working on software and then it freezes and it goes to a sort of white screen. And then it takes a while to come back to where it was. That is the recovery time I'm talking about. When a fault occurs, how long does it take for the software to recover itself and start working again? Now, we can tolerate a little bit of wait, but if this happens quite often and the recovery time takes a long time, if the user has to shut down and reboot the system, then they can get annoyed. And then they will complain that the software is not good enough. But regardless, hold on. Regardless, the user needs to have an idea of how long it will take for the software to recover. And I just heard what you said, if it would, isn't that a hardware issue? But remember, you're developing the software to operate on certain hardware. So these issues would be known, and they're known through the testing that occurs.
Yes.
So that means that user would have to the hardware requirements.
Well, that's a part of it. A part of the requirements document, just a minute, Mr. Johnson. Part of the requirements document speaks to your hardware. All right?
Right.
Mr. Johnson, you were saying?
Yeah, I'm saying, what if that performance issue is not a function of your software? For example, so that you're building a web platform and it's fetching data from an external source, and due to the user's internet connection, not able to fetch the information as quickly, which is something that the platform that you built for them has no control over.
And that is something, as you just said, is something that your software has no control over. So in that case, you would state that you would have to state what are the optimal conditions under which or what are the conditions that your software will work at this level. All right, so you would have to be able to state that this is what your software needs to operate. Remember, you're working within certain boundaries, certain constraints. All right, and once your software is operating within that area on this particular type of computer, this operating system, this amount of bandwidth, then you can say this is what the software will do. So that the user of the system, if they know that they have not provided this type of hardware, they have not provided this bandwidth, they have not provided this this operating system or this release of operating system, if they know that they haven't upgraded their operating system, then they cannot expect that type, the specified type of performance. And you can't be sued. But if everything is based on what you have said, that this is what your software needs to operate optimally, then you had better be able to meet what you have said will be the speed, the availability, response time, and recovery time of your software. And anything else that you specify in terms of performance.
But Dr. Chambers, in designing the software, shouldn't that be pointed out earlier, or that's supposed to be a part of the investigation as to
Yes, it is.
the hardware in the organization and how best it will accommodate the software, so that by the time the software program is completed and ready to be used, then the hardware would have been there already, which would have been a part of the initial discussion as to the type of hardware needed to accommodate or facilitate the software program, so that by the time the end user start to execute the software program and using it, all of those things would have already been ironed out.
And you're perfectly correct. All of that has to be done, and that is a part of your requirements elicitation. You have to know what sort of system the client will be operating the software on. You can't just decide to design the software to operate on, what am I using now, Windows 10? And the client only has Windows XP. It's not going to work. So you're going to have to say to the client, either you upgrade or the software that is going to be developed will only operate on your particular operating system. And when you decide to upgrade, it may not work. So you have to have that discussion and make everything clear. Because if you do not specify the performance based on the existing or the conditions that the client has, then you are going to be sued. Or you're going to have to pay over lots of money. And you're very clear in terms of what the performance is. Based on this kind of system, this bandwidth, or any other constraint, you say then that this is the expected performance. So before anybody else can come and complain to you, you say, did your system match this these specifications? No? Well, then I can't help you. Or I can help you, but this is outside of the scope of use of this particular software. All right? Because it can't be everything for everyone. you have to be able to identify where it is that what you are developing will work and work well. And if you notice, no matter what you are purchasing, whether a software or an app, no matter what, it tells you the required system. Isn't that so? Before you buy the software, don't you look at the system requirements to see if your system can handle that software, or if that software can be run properly on your system?
Yes, miss.
Exactly. Because you know if it can't, you're just wasting your money. All right. So the next one, the attributes. And when we speak about attributes, that's different from the performance. Now, in the attributes, we're talking about portability, correctness, maintainability, security, and there are other considerations that we look at later on down. All right, so I won't go into any too much detail with that. But let's just say that for the portability, we see how well you can take the software from one system to an upgraded system. For correctness, does it do exactly what the user wants it to do? And does it do it properly? For example, when some of you wrote your programs for me, are you sure that the calculations were correct? It may have done calculations. It may have done the output and done the output in a particular way. But were the calculations actually correct? You know, did you output in radians or in degrees if that was what you were doing? So that's that's the type of thing we're talking about when we say correctness. The next one is design constraints imposed on an implementation. Are there any required standards in effect? Implementation language, policies for database integrity, resource limits, or operating environments? What are the constraints? So again, what is it that you are designing for? And anything that restricts your design, I should say. For example, if you're writing a software for the Jamaican populace that is to be used in Jamaica for Jamaicans, by Jamaicans, would the display language be in Greek? No, the display language would be in English, wouldn't it?
Well, of course, miss, yes.
Yeah. So the language itself is a constraint. You have to be able to identify who your audience is. It's an implementation issue. Policies for database integrity. Can everybody utilizing the software have access to the database, or do they have access to specifics? For example, this is a big hint to you. In your assignment, if it is that the person has certain religious restrictions, are you going to show them the entire list of the database? And not only that, are you going to allow those individuals access to the database so that they can change it and other persons not see certain items in the database? You get what I'm saying there? If it is that you don't think, for whatever reason, anybody should have dairy products, and I am, say for example, I am the user and I don't like dairy products and I don't believe anybody should have dairy products, I should not be able to get access or gain access to the database, the full database, and remove all dairy products, because that is not right. Nobody should have access to the database. So you need to be able to ensure that the software that you're writing has certain restrictions. And those restrictions are based on the client's requirements as well. If it is that they want the user to be able to do that, then fine, they do that. But it is based on the policies that are the established policies for the database integrity.
Ms. Chambers,
Yes?
I was saying another thing that could be come into consideration for E is, for example, like countries have laws on how to treat data. Like, for example, America and Europe have the GDPR,
That's
and
right.
down here recently we had passed Data Protection Act.
All of those things come into play.
Dictate how you must deal with people data.
Yeah.
So the client wouldn't necessarily know that, but you as a developer would need to know these things so that you can
Exactly. Because if it is that depending on the software, and not even depending on the software either, all software collects information about their users. Yeah. So do you want that information available to every and anybody to access, to be able to see, to use? You have to think about all of that. You're quite right, Mr. Johnson. All right. Resource limits, that includes your memory, any kind of storage that you're using, which your operating system as well. But in terms of resource, what am I looking for? Your processing speed, all of these things. You have to, this speaks to all of that. Because it doesn't make sense to design software that require higher levels of resources and it is not available in the client system at all. Whether the one that they have or if they're going to purchase one, you have to design for that. All right, so the characteristics of good software or great software. Great software requirements, again, from the standard, they should be correct, unambiguous, complete, consistent, ranked for importance or stability, verifiable, modifiable, and traceable. So when you're developing software and you have a certain set of requirements, the requirements must be all of that: correct, unambiguous, complete, consistent, ranked for importance or stability, verifiable, modifiable, and traceable. All right, and we're going to go through all of those. Correct. Let's start out with the first one. How are we doing for time? We're good. Okay. So in terms of correct, what do we mean? No one writes a specification that they know is incorrect. That's the first thing. You're not going to write it if you know it's wrong. That is not what the client needs, so you're just not going to write that. But the discipline is keeping the specification up to date when you find that things are not correct. So what a client says today that they want may change as you proceed. So if it changes, or if what they want is no longer important, or if they need to modify that particular requirement somewhat, you have to go back and correct it. Okay? Body with me there? I'll give you a simple example. Very simple, and it might be, might never ever come up. Say you want, how many of you went to KC? Pick it on KC, past students. No KC old boys?
I'm a KC old boy, miss.
Yes, Mr. Johnson. Now, KC people love their purple, yeah? And they may say that they want a particular piece of software developed, and all text output in the graphical user interface must be purple on a white background. Now, if it is that Antonio is the owner of the company and then he sells it and he sells it to somebody who is a Calabar old boy, you need to check that the purple is still what is required, because you don't want to develop software with a graphical user interface that has an output in purple on a white background when you all know that Calabar is green and black. Things need to be changed. So that is a very simple example, but a specification, a requirement may change. All right? And specifying how a requirement should be carried out, that may change. So if it is that there are changes, you need to update the document itself. All right, so the next one, unambiguous. Software requirements are unambiguous if every requirement stated has only one interpretation. As you find the ambiguities, you fix them. And what do we mean? There should be no requirement that is left up to any form of interpretation. It must be specific. All right? Complete.
Understood.
Software requirements should be all that is needed by the software designers to create the software. So when the requirements document is done and it is taken to the designers or the developers to create the software, the designers should not have to go back to the analyst or the client to find out what do you mean by this. That requirement document has to be complete in such a way that they don't need any more information. You don't have to be going backwards and forward, which is why the requirements elicitation and the development of the requirements document itself take such a long time. Once that is done, the rest of it is easier because you don't no longer need to speak to the client to find out what they need.
Yes, I have a question.
Yes.
With this requirement specification, this is specific to a specific type of software model. Because I remember, like, for example, you were talking about the iterative thing, like you wouldn't really know all the characteristics up front.
If you remember what I said earlier on, that this what we're looking at now in terms of requirements engineering really speak to the plan-based or the waterfall method of the software process. However, in its own way, when you look at the agile or the iterative method, it still does apply in smaller increments. So if it is that you're doing the iterative method, then you would have a certain set of requirements developed for that particular iteration. Because every time you go around a particular with the iteration, you come up with an additional set of requirements. So the previous set of requirements would have been implemented in that initial design. You're not going back to change that. You're not going to be adding to it. All right? You get what I'm saying there?
Yes,
So you're not changing what went on before. You're just building on it. Building on it. Okay?
So, Miss.
Who said
Blackwood.
Yes, Mr. Blackwood.
So, in terms of the requirements document per se with the agile, it would be lagging somewhat.
What? All right. Remember, agile. No, he spoke about the iterative. The agile, we're gonna have to take a look at that because the agile allows you to change based on any changes that occur.
Yes.
But regardless, in every small step that you make, for that small step, the requirement that you're using must be complete.
Okay.
So you don't go backwards and forwards in that small step, in that particular step, or in that particular phase of the development. Once you've changed and moved on to a different phase, it's a new set of requirements.
That's true.
In one phase that you are in terms of software development, the requirements that you are using there must be complete. You move on to a next phase, then you have a new set of requirements. It must be complete. Those new set of requirements may supersede the ones that went on before, but it is a different phase of the software development process.
Understood. So we do the requirements, then the phase.
Then you do a phase change, yes.
Okay.
Okay. All right. Consistent. The requirement should be consistent in itself and consistent in its reference to documents. And this one is so simple. This example is so simple, but so profound. If you call an input start and stop in one place, don't call it start stop in another. So you don't say start and stop, and then somewhere else you say start/stop. You be consistent. Because trust me, these inconsistencies can be confusing. All right. The next one is ranked for importance. Not every requirement is as important as another. Very often, a new system has requirements that are really marketing wish lists. Some may not be achievable. It is useful to provide this information in the requirements document. So everybody wants everything when you're developing software, and I know because I've been on the client end, and I have heard persons say it must do this, it must do that, it must do that, but not everything is important. So you have to be able to understand what is it that the software is supposed to do? What feature is really the most important feature? And then you go down and you rank all of your requirements that you have obtained from the user and developed as system requirements. You have to be able to identify which ones are the most important, because you must be able to do those. Not saying that you mustn't implement all of them, but some are not as important as others.
Basically, what you're saying is, if it comes to a point where something has to be put down, you know where to compromise.
You know where to compromise. Yes. Can you excuse me a minute, please? I need to take a short break. I'll be back in 2 minutes.
Excuse me. Are the groups selected yet?
There are a couple of persons that have like 1 or 2 persons that need in order to fill a full group. You can just
Or to go about to be a part of one of those groups? I thought Mr. She would be the one selecting the group. When did she change that?
I think it was somewhere around last week. But all right. She did say, all right, send her an email, all those who are not in a group, so that she can put you in a group. Yeah. So just send her an email, and then she'll put you in a group.
Okay. All right. No problem.
Where is everybody else though? Because it's normally like wasn't like 26 close to when classes just start. Not today, but I'm talking about when the semester just started. It wasn't like 26 of us.
It was.
Because Everfast is not here. I don't see Richard. Or maybe I just don't reach him. No, I don't see him. Yeah, some of us are not here. I wonder yeah.
All right. Thank you for waiting. My apologies again. All right. So another characteristic of good software requirements, it must be verifiable. As it says, do not put requirements like it should provide the user a fast response. We don't know exactly what that is. We're engineers, we have to be specific. What do you mean by fast? 2 minutes? 3 minutes? Are you willing to sit down for 3 minutes waiting for your computer to give a response? Or are you willing to wait for 10 seconds? No, none of those will do. So you state exactly what is supposed to what a fast response means. And the example is every keystroke should provide a user response within 100 milliseconds. So you know exactly how fast it should operate. And all of this goes into the specification of the hardware. Because if it is that every keystroke should provide a response within 100 milliseconds, it means therefore you have to have processing power, good processing power, and you have to have a decent size RAM that will allow you to do that. Okay?
Understood.
Okay. I'm surprised nobody said, but miss, what if the RAM is full? That can happen. But remember, in the specification of software, or whenever you're purchasing software, it always tells you the minimum RAM size that should be available for it to operate.
Funny, I was about to say that, because that was the reason I did not mention about the RAM, because when you're doing the system specification, you normally include the minimum and recommended amount of RAM you would need.
That's
so
right.
If you have other things running in the background that's using up your RAM, you cannot blame the software. Yeah.
You have to then go and close some programs that are running so that your software can behave properly. All right, very good. All right, so we're now at modifiable. Having the same requirement in more than one place may not be wrong, but it tends to make the document not maintainable. Meaning that if you say one thing somewhere, don't say it again, because if it is that you have to change that particular requirement, you're going to have to search for it somewhere else where you remember you had placed it. You have to go there and find it and modify it there as well. So if you're stating a requirement more than one time, don't do that. It makes it hard to work with, and you might forget. And then if you forget and you have two conflicting, and now it goes back to a characteristic that we had spoken about before, which is unambiguous. You can't say one thing somewhere and then it says some unambiguous, and not unambiguous, consistent. You can't say one thing one place and then say something else somewhere else. All right, so just specify the requirement once.
In what situation would you possibly need to state a requirement more than once though?
You don't need to, but it can happen if you have a team of developers working on the same requirements document, because you sometimes do need teams. So it just means that when you come together as a team, you go through and remove any duplications. Okay. Traceable. Often this is not important and that's in a non-politicized environment. And when we talk about politics here, we're more talking about office politics than anything else. However, in most organizations, it is sometimes useful to connect the requirements. Have I lost you? Are you hearing me? Hello? You're not hearing me. Oh, goodness. Okay, can you hear me? Hello, can you hear me?
Yes, miss.
Okay, so you lost
Yes,
me for a minute there. I lost connection. I was talking to myself. And I think others may have affected others. The network seems to be going up and down nowadays. But the good thing that it didn't stop the recording.
Miss, you're not using Flow as the internet provider.
No, I am using Digicel, but I am thinking that Digicel has reduced the bandwidth so that they can carry more persons.
Oh,
Because I noticed it just generally, even when I'm not using my laptop or doing a presentation, just using my phone, the network goes up and down. And even with WhatsApp, it takes a long time for my messages to be delivered when I type them. It's not instantaneous anymore. It takes a couple of seconds. So Digicel has cut back on us. They've done it quietly. Yes, Mr. Rainford, I saw you. Saw your message.
Well, they did just file for bankruptcy.
A different.
Not Jamaica, but not Digicel Jamaica. Digicel Jamaica has money.
Sorry, I just came back. I don't know if you guys noticed that I actually disconnected. So I thought you were just talking about Digicel. I just came back.
Oh, okay. All right. So we were here on Traceable. Now, I don't know how much of what I said you heard. But regarding traceability, now there are some requirements that one person may suggest that is needed, or they may say that let us add this or remove that. You need to be able to say who said what. In most organizations, it is useful to connect the requirements to a higher level document, meaning that you need to be, you remember in the previous, in one of the previous slides, where we're looking at the patient management system, you had the one user requirement and then you had the different system requirements. So that is done so that you know where the system requirements falls in terms of user requirements. And you're also able to say who specified that particular user requirement. And what that does is to lend or to give credence to the development of a particular feature in the software, so that a point doesn't come where somebody on the management team says, why am I spending money on this? Who said that? Who told you to do this? Why are you doing this? You're able to pull your document and say, if you look at this specification here, even though it's not something that you normally show your managers, your client managers, but you're able to say, based on the user requirement listed here, this specification is required to achieve what it is that you want. And this person indicated that it was necessary for the software. Because everything will always come back to money. So it might take a longer time to develop the software if that particular requirement is there. And if it takes a longer time, it may cost more money. Or somebody might just decide that that is not the focus of the client organization anymore. You need to be able to say why it is there and who put it there. Yes, Mr. Stewart, you had a question.
Oh, I was saying, it's basically like a minute in a meeting.
Similar, but it's still a requirements document and specification document, but you just attach a name there, a time, or something that identifies why that requirement is there.
Okay, noted.
Okay. Okay. All right. Functional requirements this might sound repetitive, but it doesn't matter. Better you learn it than not. Functional requirements are statements of services that the system should provide, how the system should react to particular inputs, and how the system should behave in particular situations. Those are functionals. What should happen, what it should do, and what should happen when certain things occur or certain situations occur. And those are your inputs. All right. They also may state what the system should not do. And it says may, because we prefer to speak in the positive, what the system should do. But in certain situations where you are adamant, or where the client is adamant that this must not happen, then it should state what the system should not do. On the other hand, non-functional requirements are constraints. There are constraints on the services or functions offered by the system, such as timing constraints, the development process, what standards you're using, what systems you're using, all of that. Okay? And the timing constraints are not just timing in terms of the system process itself, but it could be timing in terms of the operating times of the software as well. Remember in that one, in the one that we looked at, where it said that it must produce a particular report at 17:30 on the last working day of the month? That would be a non-functional requirement. A functional requirement would be that a report is generated, but the non-functional says that that particular report must be generated at this time on this day. Okay? And they often apply to the system as a whole rather than individual features or services. Okay. Any questions on that? Okay, we only have 15 minutes left, so let's keep going. All right. So the functional requirements, they describe the functionality or system services. They depend on the type of software, expected users, and the type of systems where the software is to be used. The functional requirements may be high-level statements of what the system should do. And this is something that we have been talking about from the start of the class today. Functional system requirements should describe the system services in detail. So you have, again, the general user statement, which would be the general statement that the high-level statement that we've spoken of before. But the system requirements breaks down that particular high-level statement into more specific details as to what the system services are. Non-functional requirements define the properties and constraints, reliability, response time, storage requirements, device capability, system representations, all of those. Process requirements may also be specified mandating a particular programming language or method. But not just programming language, but user language or anything that is specific to the user interface. All right, all of these are constraints. If it is that you are going to be operating a system or developing software that includes accessibility features, you need to be able to say that you should have your outputs should be audible. So, you know, normally using software, you see something on the screen and you can respond. It cannot, if for the visually impaired, you could have audible outputs as well. That would be a constraint. So that tells you how you should develop the system. And the funny thing about non-functional requirements, even though they do not do anything, they don't state what the system does, but states the environment within which the system operates. The funny thing about non-functional requirements is that they are often more critical than the functional requirements. Reason is, if the system is not developed based on the non-functional requirements, then your system will not operate. Can anybody explain that to me, why that is so? Or give me an example of that.
Okay, so say for example, if we use the example from the initial example we used when we were talking about the user requirements and system requirements. Last working day of each month, a summary of drugs prescribed, their costs, and blah 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 blah. Anyway, the report, if the report isn't done at the last working day of the month, and instead just any random day of the month, then it kind of doesn't make sense. The report doesn't make because you want to know all the information pertaining to the drugs that have been prescribed for a certain period of time. So if you don't have the non-functional requirement that states that it should be executed at the last day, then that information that they get at the middle of the month, say for example, is kind of useless to you.
Yes, it would be relevant because you're not able to draw you're not able to analyze that data or make any inferences.
Right,
based on
the data won't be analyzable.
So, another way of looking at it is that maybe that data is presented at a meeting on the first day of the month. So you get it on the last day of the previous month to present on the morning of the first day of the next month. We all sit in a board meeting and discuss it. Now, if that is generated at a random day in the month, it is absolutely useless. You cannot say that for this particular period, this is what happens. And therefore, it would render the software that you have developed completely useless, not meeting the needs of your client. All right? Another simple one. If you don't have non-functional requirements and you're asked to develop this this food management system that I asked you to do, and you go ahead and you develop this for operation on a PC, and I take up my phone and said, okay, so where can I download the app? Is it in the Play Store? He said, no, it's PC. So how is it supposed to operate on my phone? I am not going to pay for that. I have a phone. I don't have a PC. What am I supposed to do? You see what I mean? That's a very simple non-functional requirement, but profound, because if it cannot operate on the hardware that the user has specified, then you have not developed the software at all. And you won't get paid. Okay? And the system would be useless for the environment that it is supposed to be used in. All right. That is the end of that set of slides. And we are at, well, we get good time, 4:51. So if I just take a look at the other one, so you can see that it still follows most of it. It talks about domain requirements, but you can read through those. I don't focus on that too much. This slides that I gave you focuses on the patient management system. So it looks at it in detail and how they are developed. Okay. This goes into requirements imprecision and speaks of completeness and consistency, which we just did. Your non-functional requirements, it shows a graphic of the non-functional requirements. Here, and you have for the patient management system, well, not just that, it speaks about product requirements, organizational requirements, external requirements. These are different types of non-functional requirements. For the product itself, for the organization that is requesting the software, it could also be your organization, development organization. And you also have your external requirements, such as any ethical considerations, any standards, regulation, legislation, accounting, safety, security. All of these are external to the software that must be included as well. Then it looks at the implementation, but I want to just skip down to the next set. Here, when we speak about the metrics for specifying non-functional requirements, You have your speed, size, ease of use, reliability, robustness, portability. So these are all that we spoke about before. Maybe not in as much detail, but I'm expecting you to read through this document. One that we did not talk about, though, was ease of use. All right. Now, there are some software that when they're developed, anybody can pick it up and utilize. They're intuitive, and the time you take to learn it is short. However, there are other software. For example, when you were using MATLAB, was that an intuitive process? Could you just open up MATLAB and get going straight away?
No, you certainly couldn't do that. Not with MATLAB.
Yeah. So there's some software.
Depends on what you're doing, though. But
it depends on what you're doing. But there's some software that you need a little bit of time for the user to be able to learn it and use it well. Some users may be casual users. Some users may be experienced users, meaning that they are the ones who know everything about the software. So it depends on what it is that you want the software to do and who is going to use it. So you'll have different trainings. So you set about and indicate for the casual user, they just need 2 days of training and then they're up and running. Or typically for the client engineers, they would take a longer training time, could be 2 weeks to a month, to learn all the features of the software. And also the help files. For the another metric for the specifying of non-functional software in ease of use, number of help frames. Is it that you just have one general page, or is it that it has in-depth help file that persons can go in and find out the solution to the problems that they had? All right. It goes on now to domain requirements, which I said I'm not going to go into with you. And then the next set of slides that we will look at on Tuesday, we will pick up here, and that is the document itself. So we went through what are functional and non-functional requirements. We went through the characteristics of good software requirements. All right. So come on Tuesday, we will look at what the document itself should look like. And there are different versions of it. I know there's one version presented here, but there are other versions as well. I'll go through 2 versions with you. And you choose to use whichever one that you want to use, which is better for you to use. Okay. All right. Any questions here?
Oh, miss, no more questions.
Crystal clear as mud?
I hope not.
All right. Okay, so as I said, next week is your next test, but I will maintain the method that, or the timing, Saturday morning, 8 o'clock to Sunday evening, 8 p.m. All right?
No problem.
Okay, very good. Okay, so I'll upload.
Could you repeat that, miss?
The test for next week will open Saturday 8 a.m. and close Sunday 8 p.m.
Okay.
In terms of what you're going to get tested on, would it include what you've done in the previous test as well, or is it just going to be basically just their
just on what we're doing now? You've already been tested on everything up to risk, so this test will be focusing on requirements.
Okay, noted.
All right. That doesn't mean that you should forget everything, because everything will be in your final exam.
Noted.
Okay. All right. And just so you know, remind you that there are 5 tests. Well, there are really 4 tests, and your presentation will be the 5th one. Each of those values 6%, so your total test grade is 30%. Your final exam is valid at 30%, and your project or your assignment is valid at 40%. All right.
Yes, miss.
So you know what to maximize on. All right. So for those of you who are not in an assignment group, please send me an email and I will go through and make some recommendations there. All right. And for groups that are missing a few members, you can also let me know so that I know how many people I can add or recommend to you. All right, so we will end it there. Thank you, ladies and gentlemen, and I will see you same time next Tuesday.
You take care.
Okay, take care.